Okay, we're going to look at 7.2, multiplication and division of rational expressions. And so let's start first with multiplication. And when you multiply rational expressions, you actually want to do what you did in 7.1 first, which is first simplify them. And by that I mean if you can factor, and then cancel any like factors before actually multiplying. So if we look at A, this has already been factored. There's nothing that can be simplified in either of these fractions. So I look for any common terms or factors that I can simplify. And the first thing I see is this r plus 2 can be canceled with this r plus 2. And then looking, I also see that the 4 and the 20 can be simplified. I'm going to divide both by 4. So 4 divided by 4 is 1. 20 divided by 4 is 5. And then last, I see that the 3 and the 6 can be simplified. I'm going to divide them both by 3. So 6 divided by 3 and 3 divided by 3. Once you've done all that, you can go ahead and multiply. Just make sure you don't accidentally drop a term. So in the numerator, it looks like I have a 2 times 1, which is 2, and an r. In the denominator, we just have a 5. So we have 2r over 5. I just want to show you, you can also write this as 2/5 r. These mean the same things. Two different ways to write the same thing. So either one is correct. Okay, so let's look at another example here. In this case, we actually need to simplify this numerator 10b plus 30 by pulling out the GCF of 10 first. So I'm going to rewrite the first equation, or excuse me, the first fraction. And then over in the second one, in the numerator, we're going to pull out a 10. And this becomes v plus 3. And then rewrite this. Okay. Once you've factored it, you can go ahead and look for any common factors. Remember, if I have a v plus 3 here, think of this v and plus 3 having to stay together. You can only cancel this if you have something that's exactly the same, which we have in this numerator. So both of these v plus 3's can cancel. And then this is where you need to be really careful. Remember, this v plus 10 can only be canceled if there's another v plus 10. The v and the 10 have to stay together because of that plus sign. So you cannot cancel this 10 with this 10. That doesn't work that way. This whole thing has to stay together, so you might want to put parentheses around it to remind yourself. Then I'll go ahead and multiply. In the numerator, we have a 10, and then in the denominator, we have a v plus 10. Okay, for our third example, this needs to be simplified by being factored before we can even try and cross-cancel. So in the first fraction, in the denominator, we can pull out the GCF. What's the GCF of 7x and 35 is a 7. And this becomes x plus 5 times, I'll rewrite the denominator first because that cannot be simplified. In the numerator, I have a trinomial, x squared minus 3x minus 40. So we can factor this. I need two numbers that multiply to be negative 40 and add to be negative 3. And that would be a negative 8 and a positive 5. And remember, don't always start from scratch when you're factoring. So notice that my factors, not just one of them is in the denominator, but both of them are, the x minus 8 and the x plus 5. So I'm going to go ahead and cancel like factors. So I can cancel the x minus 8. I can also cancel the x plus 5s. And again, remember, we cannot cancel these 7s because this 7 has to stay with the x because of the plus sign. So it's x plus 7 over 7. And that's all we can do. That's our simplified answer. Okay, so now division is very similar. The only difference is you have to remember when you divide fractions, this is true for any fractions, you need to multiply by the reciprocal. So this is the first step that you need to do before you actually go ahead and simplify. So I'm going to rewrite this whole thing as a multiplication problem. So I'm going to have 7a squared over 7a cubed plus 56a squared. Change your division to multiplication, and then you flip the second fraction. Okay, now I can go ahead and start factoring and simplifying. So the 7a squared is in simplified form. In the denominator here, I have 7a cubed plus 56a squared. I can pull out the GCF, and the GCF of 7 and 56 is 7. And then for the GCF of a cubed and a squared, you take the smaller exponent, so a squared. And when I do that, I'm left with a plus 8 times, for the other fraction, I have a 2 in the denominator. I need two numbers that multiply to be negative 8 and add to be a positive 7, and that would be a positive 8 and a negative 1. Okay, now that this is factored, I can go ahead and cancel any like terms. So I can cancel out these a plus 8s, and I can cancel the 7a squared, since those are together. And that is it. So you can go ahead and multiply, and you're going to have in the numerator just a minus 1, and in the denominator 2. Okay, so let's try this again. If you want to save a step, you could factor this first fraction and then flip the second fraction. You just want to remember you always need to convert this division to multiplication before you start canceling. So I'm going to go ahead and factor this first fraction. Multiplies to be 16, adds to be 10 would be 8 and 2. And then in the denominator, I need two numbers that multiply to be 8 and add to be 6. And that would be 4 and 2. Then I'm going to change this division to multiplication and flip the second fraction. And we're going to look to cancel. So I can cancel my x plus 4s, and I can cancel my x plus 2s. Multiply across, and all you have is x plus 8 over 1, but you don't need that over 1. It's just like writing 5 over 1, which is just 5. So your answer is x plus 8. Okay, so let's look at a word problem with a rational expression. It says the number of people in thousands banking online is given by this expression where t equals 0 corresponds to the year 2000. How many people were banking online in 2007? So 2007 basically means you're 7 years after 2000. So in this case, t is going to be 7. So you're just going to rewrite this expression, but instead of t squared, we're going to put 7 squared. We're just going to plug in 7 for t. And then you're going to put this into your calculator. You just have to be careful if you're going to put this in all at once where you have your parentheses. So if you want to put this into your calculator all at once, which I would try, is you need to start with parentheses to show that your whole numerator, you have to delineate your whole numerator by starting and ending with parentheses, and then hit the division key and then another parentheses around your whole denominator. And then you would go ahead and put that in, and you should get, when you round to 1 decimal place, 45.6 thousand. So almost if you round it to a whole number, almost 46,000 people. Okay, and then the last example says write a rational expression with one variable for which the excluded value is -4. So excluded value, remember that means what makes the denominator 0, what makes the rational expression undefined. So you can write any rational expression. If I wanted to pick a really simple one, it would just be 1 over, and the excluded value needs to be -4, which means when I solve, I get x is -4. So that would be x plus 4. 1 over x plus 4. X cannot be -4 because -4 plus 4 would be 0. So that's just one of the simplest examples you could pick for that